This is section 6.1, solving inequalities using addition and subtraction. The graph of an inequality with one variable is on a number line. If it's a less than or greater than inequality, you have to use an open circle on the data point because that's not included in the answer or your solution set. If it's a less than or equal to or greater than or equal to, you have to fill in the circle at the data point because it's actually included in your answer set. That point is part of the solutions, so it's got to be in a solid color that matches the arrow that you're drawing. For example, to graph x is less than 3, we would find 3 on the number line. We would circle it because it's a less than sign. It's not included in the data set. And we would draw our arrow going to the left. Remember, on a number line, left is always less than, and right is always greater than. To graph x is greater than or equal to -1, you would find -1 on the number line. But because it's greater than or equal to, the answer actually could be -1. That means it has to be included in your line, so you put a solid circle on -1. Because x is greater than -1, you must draw your arrow to the right. You have to be able to write and graph inequalities from simple word problems. For example, if you're told that the highest recorded temperature in the United States is 134 degrees, you have to be able to write an inequality to describe all the other temperatures recorded in the United States. Since 134 degrees is the highest, all other temperatures would be less than 134. So you would find 134 on the number line, and you would put an open circle there because it's not included in the data set. X has to be less than 134, so you would draw your arrow to the left. You also have to be able to write inequalities from graphs. So given the following graph, write the inequality. Well, since the graph is going to the right, we know that it's either greater than or equal to. Because it's an open circle, it can only be greater than. So in this case, x is greater than the data point given, which is -6.5. That means that all the numbers greater than -6.5 are solutions to the inequality. The addition property of an inequality says that adding the same number to each side of an inequality produces an equivalent inequality. In other words, if a is greater than b, then a plus some number c is greater than b plus some number c. If a is less than b, then a plus c is less than b plus c. Because this property is true, you can solve inequalities by isolating the variable, adding to move everything to the other side. For example, in x minus 5 is greater than -3.5, to solve for x, we would have to add 5 to both sides, and we can do this because of the addition property of inequalities. So when we add 5 to both sides, we get x is greater than 1.5. To graph this, you find 1.5 on the number line. You'd put an open circle there because it's a greater than sign. 1.5 is not included in the solution. The arrow must go to the right because it's greater than. So that's what I've drawn in green. This means all numbers to the right of 1.5 are solutions to the inequality. You can check a number to the right to see if this works. Always check your solution to make sure it's all right. The subtraction property of inequality says that subtracting the same number from each side produces an equivalent inequality. So if a is greater than b, then a minus c is greater than b minus c. See, as long as you're doing the same thing to both sides of the inequality, it's just like doing the same thing to both sides of an equation. It will keep it balanced. So here you can subtract the same number from both sides and get an equivalent inequality. If a is less than b, then a minus c is less than b minus c. So let's take a look at the example solving using subtraction. So if we have 9 is greater than or equal to x plus 7, to isolate x, we have to subtract 7 from both sides. So 9 minus 7 is greater than or equal to x. which means 2 is greater than or equal to x. Usually we write inequalities with a variable on the left-hand side, so you need to turn this around. This is going to be x is less than or greater to, less than or equal to 2. So when we graph this, we find 2 on the number line. We need to put a solid circle on 2 because of the equals part of this inequality. And because x is less than 2, you need to draw the arrow to the left. Let's try a word problem. If when you're boarding a plane, your bag can weigh no more than 50 pounds, and you know your bag weighs 16.8 pounds, we want to find the possible weights you can add to your bag and still not go over the weight limit. So what you do is you start with the beginning weight that you have of 16.8, and you know you want to add some amount to that, we're going to call that x, to stay less than or equal to 50. So your bag can be 50 pounds. It can be less than 50, that would make it safer, but it could be exactly 50. So in this case, when we write the inequality, we have the starting weight of 16.8 plus some amount x, that must be less than or equal to 50. To solve it, you have to subtract 16.8 from each side. So you get x is less than or equal to 33.2. That means your bag must be less than or equal to 33.2 pounds. So we draw a solid circle on 33.2 and draw our arrow going to the left because it's less than or equal to.